So I think I may have gotten these two videos a little bit mixed together. I guess maybe I'm used to them in a different order. Maybe order doesn't matter, but this one is radical expressions. So radicals, of course, are these guys, and we just talked about what it means to have, you know, a like this. So you may have to deal with these as expressions, and of course it is an expression, either one of these is an expression, but if I have something like 4 cube root 81 minus 5 cube root 3, that might look like something that you can't do anything with. Normally we think about looking for like terms, and your like terms normally x or a or b or x squared or root x even, but this doesn't look like it is. But what we have to do is we have to simplify this guy first, which is what I kind of got in a previous video that maybe didn't belong there. Maybe it did. I'm not really sure. But anyway, if we simplified this guy, then we might have like terms. This one we want to simplify also, but since 3 is prime, we're done. You know, if you can't factor it, there's nothing to do. So I'm just going to write, I'm going to work on this, okay? So I'm going to leave the 4 and the cube root, and over here I'm going to leave the whole deal because there's nothing. Let's just say we're factoring it because that is the factorization it's done. So 81 has a 3 in it. And of course I could do a little tree, right? I could say, well, I know it has a 3 in it. And then you could even use a calculator to get the 27 if you needed to. That also has a 3 in it. And when I wrote 3 times 27, I really should have marked that out. And the 3 times 9, I should have marked that out. And the 9, 3 times 3, I should have marked that out. So I have 4 3s. You don't have to do it like this. That's a way to kind of make sure you're not messing it up. So because that's a 3 also, a lot of 3s running around, because that's a 3, I want to look for sets of 3. So I take the set of 3, and I'm left with 1. So I have 4 times 3, is that set, cube root 3. 12. So now I have like terms. Now this is 12 times an object minus 5 times that same object. It doesn't matter what the object is, right? So I can factor it out. And that's 12 minus 5. Let me take just 1 minute to talk about what factoring is doing. Because we're going to be factoring out things with rational exponents, and that's kind of confusing to people. So if I have, say, 3x minus 9, and I factor out a 3, I can't go around multiplying by stuff, and I can't go around dividing by stuff, right? If I do it on either side of an equal sign, that's fine. But this is just an expression. This equal sign means I'm trying to rewrite it. It's not an equation that needs solving. So when I do this, I have to either divide or multiply by a useful form of 1, or I need to add or subtract a useful form of 0. Those are really the only things we can do to an expression without breaking a rule, okay? So when I write this on the outside, here's what I'm actually doing. I'm saying there's a 3 everywhere, so I'm multiplying by this useful form of 1. Okay? But then what I do is I leave the top one out here and I move the bottom one inside. So I leave that outside. So that it's still there, still just multiplying by 1. And then maybe I split it. Maybe I factored the top, but that's kind of circular, right? Because that's what we're trying to do. So what I'm doing right now is trying to prove to you basically why factoring is dividing and multiplying. So then that becomes useful maybe if you find yourself confused about like terms. So if I had, what did I have? 12 cube root 3 minus 5 cube root 3. Maybe that looks scary. Maybe it's just kind of confusing. So what you do is you're multiplying by cube root 3 on the outside, and you're dividing by cube root 3 everywhere on the inside. Okay. And then you can see that's just a 7 in there. And that's a weird way to write it, so you change it like this. Okay, so let me do something else. I did simplifying those in the previous one, so hopefully that's okay now. Let's say that I had 12x to the 7/8 minus 6x to the 3/8. So if I had instead, just as a note, if I had 12x to the 7th minus 6x to the 4th, you'd say, well, factor out the 6, and you'd factor out the lowest power of 4, right? X to the 4th in this case. And then you'd divide. So 12 divided by 6 is 2. X to the 7th divided by x to the 4th is x cubed. This is 1. We're going to do the same thing. It's just in this case, the lowest power of x is 3/8. So it's a little different. So I'm still going to factor out a 6. And now an x to the 3/8. So maybe I put a step in here. This you did in your head. Maybe this one you don't do in your head. So 12x to the 7/8 divided by 6x to the 3/8 minus 6x to the 3/8 divided by 6x to the 3/8. So 12 over 6 is 2, and I have x to the 7/8 minus 3/8. I should have written this down. And then this, just like here, this is 1. So I would put 6x to the 3/8 times 2x, let me write this down here, 6x to the 3/8 times 2x to the 1/2 minus 1. 4/8 reduces to 1/2, so I'm just reducing it, okay? Now we also just finished talking about negative exponents. So what if instead I had 6x to the 5/8 plus 4x to the minus 3/8. So this is one of those times that you might want to show the divide multiply version that I was talking about earlier, because this looks pretty confusing. I want to mention, side note, hello, there we go. With the 6 and the 4, when I say I want to factor out a 2, I'm actually doing the same thing I did with the variables, okay? Because 6 is 2 to the 1 times 3 to the 1. 4 is 2 to the 2, but there's like this 3 to the 0 if you want, right? But if I look at this and say I want the lowest power of each number, the lowest power of 2 is 2 to the 1, the lowest power of 3 is to the 0, so I don't write it. That's where this comes from. It's the exact same situation. The lowest power of x is x to the minus 3/8. If this was positive 3/8 and this was negative 5/8, this would still be, the negative one would still be the lowest, okay? Lowest is most, leftmost on the number line. So I factored this out, and I feel like you wouldn't just say, oh, I'm going to factor out x to the negative 3/8 from x to the 5/8, so that's clearly x. I think that that is not going to be obvious, so it might be helpful to use this method, especially in these cases. Okay, so then I can see 2x to the minus 3/8. 6 over 2 is 3. X to the 5/8 minus a negative 3/8 is x to the 5/8 plus 3/8. So that's x to the 8/8. And then over here, that part cancels and I just get 2. Okay, so this is an example of a time that you might want to go ahead and do this whole process. And I think I've now covered everything from this review chapter, and we'll move on to 1.1.